Hello children, welcome to another video. Today we will be learning about the structure of an atom. But before we start, please do make sure to subscribe to Press Learning.
So, what are atoms and molecules? Basically, atoms and molecules are the fundamental building blocks of matter. Protons, neutrons, and electrons, these are the subatomic particles, which means that an atom is comprised of these three particles. Now let's talk about the subatomic particles. Electrons. J.J. Thomson first discovered electron. The presence of new radiations in the search gas discovered by E. Goldstein in 1886 are called Canel rays. These rays are called protons and they are positively charged. Hey, one of the interesting thing is that proton and electrons are equal in magnitude but are opposite in sign. That is, protons are positively charged while electrons are negatively charged. The mass of a proton is taken as 1 unit and its charge is +1, while mass of an electron is considered to be negligible and its charge as -1. Well, J.J. Thomson first proposed a model for the structure of an atom, that is the location of proton and electron. Now moving on to Thomson's model of an atom. Thomson proposed the model of an atom to be similar to that of a Christmas pudding. He proposed that an atom consists of a positively charged sphere and the electrons are embedded in it. Secondly, the negative and the positive charges are equal in magnitude, so the atom as a whole is electrically neutral. Moving on to the next model of an atom, that is Rutherford's model of an atom. Rutherford proposed that there is a positively charged center in the atom called the nucleus. The electrons revolve around the nucleus in circular paths. The size of the nucleus is very small as compared to the size of the atom. Okay, here's an important point, guys. Alpha particles are doubly charged helium ions. Please make sure to note it. Next is Bohr's model of an atom. As per Bohr's model of an atom, only certain spatial orbits known as the discrete orbits of electrons are allowed inside the atom. Secondly, while revolving in the discrete orbits, the electrons do not radiate energy. The orbits, also known as shells of an atom, are represented by the letters K, L, M, N or the numbers 1, 2, 3 and so on. Next topic is neutrons. Well, in 1932, J. Chadwick discovered neutrons. Neutron doesn't pose any charge, means they are neutral in nature. Neutrons are found in the nucleus of all atoms except hydrogen. The mass of a neutron is nearly equal to that of a proton and it is denoted by the letter N. Now, distribution of electrons in different cells. Distribution of electrons into different orbits of an atom was suggested by Bohr and Berry. There are certain rules that need to be followed while distributing electrons into different cells. First, the maximum number of electrons present in a cell is given by the formula twice n squared. Secondly, the maximum number of electrons that can be accommodated in the outermost cell is 8. Thirdly, which is the most important one, unless the inner cells are filled, electrons cannot be accommodated in a given cell. Moving on to the next topic, that is valency. So what is valency? The combining capacity of an atom is called valency. The electrons present in the outermost shell of an atom are known as the valence electron. Examples: helium has 2 electrons on its outermost shell, hence its valency is 0. An outermost shell which had 8 electrons are said to possess an octet. Atoms achieve an octet in the outermost shell by gaining or losing electrons. Next topic is atomic number. Atomic number is defined as the total number of protons present inside the nucleus of an atom. That is, atomic number equal number of protons. It is denoted by the letter Z. Then comes mass number. Mass number is defined as the sum of the total number of protons and neutrons that are present inside the nucleus of an atom. That is, mass number equal the number of protons plus number of neutrons. It is denoted by the letter A. Protons and neutrons are collectively known as nucleons, and the correct way of denoting an element, its mass number and atomic number is shown here. Okay, citing an example of nitrogen, it can be written as shown here. Next topic is isotopes. What are isotopes? Isotopes are the elements that have same atomic number but different mass number. For example, there are three isotopes of hydrogen, namely
Protium, deuterium, and tritium.
citing few more examples, we can take carbon and chlorine. Carbon C612 and C614, which means that the atomic number are same but the mass number are different, that is 12 and 14. Likewise, in chlorine Cl1735 and Cl1737, it can be represented this way. If an element has no isotopes, then the mass number of its atom would be the same as the sum of the protons and neutrons in it. Whereas, for those elements which occur in isotopic form, we need to find out the percentage of each isotopic form and then the average mass is calculated. Applications of isotopes. An isotope of uranium is used as fuel in nuclear reactors. An isotope of cobalt is used in treatment of cancer, and iodine is used in the treatment of goiter. And the last topic which you have in your NCERT is the topic of isobars. What is isobar? Different elements having same mass number but different atomic number are called isobars. For example, calcium and argon. The total nucleons, that is the sum of protons and neutrons, is the same in these two elements.
With this, we came to the end of today's topic. Hit the bell icon to stay tuned to our latest updates and let me know the topics in which you want me to make videos. Till then, take care. Bye bye.